good afternoon, or good morning, or good evening, depending where you are, and welcome to this Austmine AROSE information session on space innovation opportunities. My name is Chris Gibbs Stewart, and I'm the CEO of Austmine, and I will be your host today. I join you from the lands of the Gadigal people, and I'd like to acknowledge the traditional custodians of the lands where we meet on all today, and pay my respects to their elders past, present, and emerging, and a special welcome to any Aboriginal or Torres Strait Islanders people who join us today. I'd like to welcome Michelle Keegan, Program Director Resources and Space at AROSE, who is my co-host today. We're also very pleased to be joined by Jonathan Stock, Director, USGS, National Innovation Center, on detail to NASA Ames Intelligence System, who is joining us from San Jose, California. Now, just a brief overview of the information session today. After my introduction, I'll hand over to Michelle, who will go over the 3 space innovation opportunities that we are seeking solutions for, and on which we have collaborated with the USGS and NASA Ames. I'll then go through the timeline and process of putting forward your solutions, and we'll finish with questions. Questions, of course, can be asked at any time in the chat box. And if we don't have time to answer all the questions during this session, we'll do so directly with those who have asked the questions. This is an exciting time for us as we explore advancing innovation and technology, not only in mining and minerals, but in perhaps one of the most exciting and pioneering industries in the world, and that is space exploration. While a new area for Austmine, this is a culmination of the work that we have been doing for the last 35 years in promoting the value of innovation and technology in mining and positioning our members as the best in the world in high-tech, advanced, groundbreaking solutions. It's great that not only is mining listening, but now other industries are recognizing our problem-solving abilities and wanting to partner with us to leverage our expertise, adapt our solutions, create new possibilities, and bring what we have to offer off-world. The opportunity we have before us today is to inform the space community about our terrestrial mining and minerals expertise, knowledge, and solutions, and to really position Australia Mets as the first choice technology partner and valued solutions provider to the space industry. These opportunities for Australian and Mets have arisen due to the work of AROSE, whom we are partnering with today, and conversations that we have had with the USGS and NASA about the expertise that our members offer. But instead of me talking about our capabilities, these opportunities allow us to truly showcase our smarts and our world-class solutions. Now, what I want to make clear is that though we have 3 specific opportunities to respond to, this is not a formal request for proposal by NASA, an immediate purchase order, nor committed funding. What this is a beginning of a journey and an opportunity to put our best foot forward, show what we have to offer, and just as we have transformed mining, be part of transforming how we may live in the future for the benefit of humanity. And when it comes to mineral exploration, extraction, and processing, who better but the Australian met sector, and why not on the moon? As mentioned before, as part of our strategic partnership with AROSE, we have joined forces to bring these innovation opportunities to our members today. And with that, I'd like to hand over to Michelle Keegan, who will talk about AROSE, its mission, and the opportunities we have before us. Over to you, Michelle.
Thanks, Chris, and great to be here today with you and with John and the Austmine team and everyone here online as well. Did want to take the opportunity, if we move to the next slide, just to talk a little bit about AROSE. We're an organisation that's been around since 2020. Some of you may know of us, and a number of you probably don't already. But we have proudly partnered with Austmine, and we've been working together for over a year now, really because of all the opportunities that Chris has mentioned to be able to take the met sector to the space industry, and also vice versa. We really think that some of the technologies that the space industry has to offer can actually help with changing the value proposition that METS companies have for mining companies. So really, we're at a great time now in the space industry with the growth that is happening, with the investment that's happening globally, to be able to take advantage and be a part of this more specifically. So if we move to the next slide, AROSE is an industry-led consortium. We are made up of over 15 members. We're actually formed in 2020 by the now Deputy Administrator of NASA, Pamela Malroy. She was actually doing some work out in Australia, looking at building a space strategy. It was at the time of the space agency being created. She saw the remote operations capability that we have up in the northwest of Australia, largely led by miners such as Rio Tinto, BHP. Looked at the scale in which we operate on a daily basis, the material moved, really strong remote operations capability, and suggested that it would make sense to be able to establish ourselves in a way that we can take this capability to space. More specifically, her quote actually that she states at press conferences here in Australia and around the world was that if we can run a facility in the Pilbara from almost 2,000 kilometres away to Perth, it's going to be a piece of cake to do that on the moon. So great to have that recognition from the space industry, and Pam Malroy was actually formerly an astronaut as well. But when she saw this capability to be able to take this, what we have to space, it was also acknowledged that it really is an uncontested area in the space sector. So there's much more for us to be able to take than just what meets the eye. So really, after her insights were created, there are a number of companies that said, we believe also in this opportunity and we want to stand up this consortium. And those were 5 founding members: Curtin University, University of West Australia, Nova Systems, Fugro and Woodside. The other organisations are at the bottom of the slide, and you can read them, but Austmine there as a partner is also a key one. So the AROSE has actually been granted funding from the Australian Space Agency to actually start bringing that capability to the space sector, and that's about designing Australia's first lunar rover. So this really is about taking our remote capabilities to space through the Artemis Accord, which is pretty exciting. But we see that, to be able to position ourselves in such a way that we can contribute to the space sector and bring space technology back to the resources sector, it's important to have the right advisors around us. We've got a really well-recognised resources industry advisory board, of which Austmine also sits on there, along with a number of other companies. We also have a space council that helps guide us around the opportunities in space. So really, as a consortium, it really makes sense for us to bring together different communities from across the Australian environment to be able to participate in really showcasing our technologies across the globe. If you want to know more information about AROSE, please go to our website. But to take us further into the opportunities and what you're here to learn more about today, and what you've seen on the Austmine website already, hopefully through the Mine Innovate platform, do want to acknowledge actually back in February, the Australian Space Agency was also looking at the MET sector and trying to understand more about what the sector has to offer. At that time, they did actually run a formal expression of interest process, and that was about identifying capabilities that we have under their Moon to Mars initiative. They wanted to understand capabilities we have to be able to update their own state-of-the-art knowledge of the industry, academia and research capability, but also for them, it was actually about identifying future opportunities and collaborations. And that was really about moving forward with organisations from mining and resources sector, METS companies and innovations, robotics organisations, quantum, and many more. And they wanted to know how this could relate to not just their Moon to Mars initiative, but also to NASA's Moon to Mars architecture and the architecture represented by other agencies around the globe. So this too is in the same vein that they were wanting to understand more about the sector. We are at the same stage. I guess another couple of points to note is that we don't see that this is a one-way piece of information. We think, honestly, if we can understand more about the capabilities that we have here, we start to set up ultimately a conduit of information and knowledge and capability that can hopefully lead back to more innovations and advances here in our sector at a time where challenges probably couldn't be tougher, with looking at how we operate on a smaller footprint, getting to zero emissions and very fast paced timeframes. So we hope that information that we start to gather and create conversations with can then ultimately lead to accelerated discoveries on Earth for critical minerals and other minerals, and faster project builds as well. So we really do see this as a bigger game, both for contributing to the space sector, but also for being able to contribute back to Earth ultimately in everything that we do. The difference between what the Australian Space Agency did earlier this year and what we're doing now is we've tried to narrow in on 3 really specific areas. And so in some of the discussions we've had, trying to understand what they could be with Jonathan Stock online today, the 3 areas are as represented here today. So it's about detecting and assessing minerals on the moon that can be used for off-world manufacturing. There is also an opportunity around trying to reduce geologic uncertainty by bringing together data and fusion of that data from different sensor platforms. And lastly, off-world SLAM. So we'll move into each of these individually. And if we can move to the next slide. So the first opportunity is really about sensing solutions. And so the idea here is that in the space sector, there is a need to understand more about the minerals on the moon. And ultimately, these are to be able to be used in off-world manufacturing. Some of the more specific minerals that we want to call out in this first pass is zirconium, barium, fluorium, and sodium. The environment is different on the moon, and this is really important. And so the solutions that we are seeking do need to be low size, low weight, low power. And that is also then being able to achieve a 0.05 to 5 weight% noise for a range of different particle sizes. The solutions are really intended to be able to create small prospectivity maps and larger characterization maps. If you think about what's happening in the space sector today, the space manufacturing area is small, but it is a very large growth sector as we see it. And so thinking about the different conditions that we have there in space is really important to be able to bring the solutions to bear. The materials that we derive from space will be able to be used for manufacture of for example, lower cost, high bandwidth cables. And that can be used for many different areas, including medical imaging, telecommunications, and surgery and diagnostics. So there is quite a wide area of use of the cables, of which the cables can only be made from off-world manufacturing, which need to be created from minerals. So we know that others have already manufactured high bandwidth cables on the International Space Station, and given the wide uses, we want to be able to go upstream to start to detect the minerals possible for this. We know that there are other lab-based methods, including XRF and XRD to do this. There are field-based methods like handheld XRF, LIBS and Raman spectrometers. But there have also been issues with these in the past. So we detect and assess minerals. We have done for many decades on Earth, and there's a huge amount of innovation, as Chris has already acknowledged from people represented on the call today. So the right resolution is really important. And therefore, we want to understand really what does the industry have today? Where are you pushing the boundaries? What products or solutions do you have that you think can contribute to what's needed in the space sector? So before I go to the next area of opportunity, do want to just throw to John and Chris just to say, is there anything else that you want to add to be able to really clarify what does this look like before we seek more questions at the end?
Chris, do you want to make any comments before I do?
The only comment I'll make is you can see more about the opportunity on the Mine Innovate platform, which gives a bit of a background and the goals of what's trying to be achieved here. But over to you, John.
Thanks, Chris. Hi, folks. I'm John Stock on detail to NASA from USGS. I think, Michelle, there are two sort of things I might add to this, and one is obviously we care about in situ determinations of these, and we also are really interested in any techniques that allow us to do remote sensing so we can narrow in on potential concentrations, right? And we imagine that this is one example of in-space manufacturing where some folks have made a very strong return on investment case. We expect there'll be others. And so, well, it's a good time to explore from the METS community what the low size, weight, and power opportunities are to find, essentially make prospectability maps for things that might be components to those commercial products. So I think I'll leave it there, Michelle. Thanks for a great summary.
Okay, all right. Thank you, John. It was actually funny when I first met John. He indicated that there was a lot more to be learned about the subsurface of the moon. Equally, if you think about what we do here on Earth, we need to discover critical minerals much faster. Everyone kind of says, hasn't NASA got it covered? But at the end of the day, there's a faster kind of discovery rate that we want on Earth and other planetary bodies. So we really recognise that the capabilities we have are so great in Australia. The level of innovation and acceleration of that is very fast. So we want to be able to take advantage of that, and hopefully we can collaborate a lot more on speeding up both of our paths. So the next opportunity is about data fusion, and ultimately the goal is about reducing geologic uncertainty. So this is, as I said, also focused on understanding the surface and subsurface of the moon. If we can use methods for data fusion that enables us to bring together the data that we bring off, multiple different geophysics sensors and other types of sensors, we think that we can improve the certainty of the maps that we're ultimately creating. Like with the other solutions we're looking at, logistics are important. Weight is very important in the environment. So ultimately what we're trying to do is bring together the data that's collected from different sources. So that could be from magnetics, could be from great emitters, electromagnets, hyperspectral. I guess there are a number of different sensors used in different exploration projects on the moon, upcoming in many missions, as well as have been on Mars. But if we can't bring this together with the right fusion mechanism, the maps aren't necessarily as certain as what we want them to be. So there could be multiple sensors that are used. The mineral requirements, as stated here, 2 or more sensors under 15 kilogram payloads. So that's a really important point. The current collection of geologic material in space is often a single measurement mode, which really limits multiple data points being interpreted within a single framework. So NASA already collects data using airborne, gravity, and the other sensors I've already mentioned. Most sensor solutions, we see kind of depend on high capacity crewed aircraft of what we kind of already do. Drones use visual, hyperspectra and other methods. But many instruments are kind of often too heavy for drones as well. So we don't currently see that there's a standard approach for multi-sensor data fusion right now. And so the best geologic interpretation possible. Therefore, given, as we mentioned many times, the acceleration in this area just to speed up our own discovery, we really think that there could be solutions out here in the METS community. I guess this is probably, a harder one to potentially talk to than some of the other opportunities. So I might hand over to you, John. I guess it's an area you've been thinking about for a while and have also done some experience with different organisations. But do you want to add anything to this one?
Thanks, Michelle. So I guess for folks who are listening and wondering exactly what we mean by this one, the broad goal obviously is to shine a flashlight into the subsurface, to do rock body differentiation through, essentially remote sensing in the subsurface before you dig, before you drill. The challenge to that, is I think many folks on the line will know, is that no single sort of geophysical technique tends to rule out all the models. Most of them have multiple different models. And so the usual solution is you go out with a technique, you get a survey, then you go back with a different technique, get a different survey. Many of the parameters may be different. Then you go into the lab, try and fuse those data sets together, and then use them to rule out particular models for subsurface. The question here is, well, A, that's going to be difficult to do on if we send probes off to Mars, right? That concept of operation doesn't work so well. So what would it look like if your platform has multiple different geophysical sensors on it, and it has, let's say, onboard model generation, and then you start having the data sets talk to each other in real time so that you can decide where you want to add additional data density, and which models you can or cannot rule out with the sensor arrays that you have on board. That's a really challenging prospect, but at the end of it, for off-world, is we could actually image the subsurface in a way that's just positive for a particular, let's say, model of the subsurface ore body. On-world, one can imagine that it would dramatically reduce the time you're spending moving data from the field to the lab, and then going out and resurveying, because you do it once or a couple of times on site, and you get the data density you need to rule out particular models, right? So it's a very attractive idea. There are folks who are already beginning to take a chew into it. We think maybe Australia has chewed a bit more than others, and so that's a great place to look for information for you folks. Back to you, Michelle.
Thank you. And yeah, really good point. I guess we all want to try and get to real-time resource modeling. So if we can do that from this is kind of the first fusion point, then that would be a fast way forward. I think we'll move through to the next opportunity, which is around the use of SLAM off-world. So this is, as you can see here on the slide and would have read already, it's really about an accurate system for near real-time surveying, both above and below ground, to produce 3D point clouds. Already mentioned what Pam Roy saw in the resources community when she was out here a few years ago and stood up AROSE. And so we really think that, given our experience in remote operations and autonomy at scale, organisations that are on the line today may either represent OEMs or may represent or be a non-OEM or technology organisation that is already kind of advancing the use of SLAM technology in operation and mining. So really, we know that there's a lot of work happening here in Australia, both above ground and underground, with respect to autonomy. So if we can start to use this technology to be able to develop the surface maps, this is going to be really important on the moon and other areas. So the system does need to have low latency to be able to provide the simultaneous localization and mapping, and that would be from one or more robotic agents. The near real-time surface or subsurface map would need to be acquired over multiple hundreds of meters, and the near real-time position estimation relative to the surface or subsurface map is required. We're talking really about future presence off-world, where there is a lunar economy, so that is, on the moon. There is more activity on Mars eventually as well, and so that will require autonomy to be able to create, both build those environments and enable us to operate in those environments with less people doing that work, in the same way as we're looking for less people and our own operations into the future and more off-site running analysis. So the work that will be done by multiple autonomous systems will rely on these low latency maps. So NASA's looking to, ensure that this sustained human presence off-world can occur, which means at the end of the day, by understanding the capabilities we have, being able to stand up, pilots into the future, depending on what the capabilities are and where conversations could go. This all forms part of the planning stage that ultimately helps to deliver on the Moon to Mars objectives and goals that are laid out and are also kind of public. So near real-time surveying represents or needs to represent the evolving topography, as we start to kind of move around these other bodies. Currently, we know that technologies kind of depend on being airborne in some circumstances. Airborne systems like, drones won't work in many of the off-world settings with little to no atmosphere. And some of the scanners that we kind of use will be difficult or impossible to use as well. So really, we are accelerating what we do in this area, to understand what we do have and then be able to overlay the environment and look at how this can be deployed off-world is what we're trying to achieve. So yeah, I might hand back to you, Chris, or John, just to add anything more to this opportunity.
I think I'll hand over to John.
Thank you, Chris. Thank you, Michelle. Yeah, I think this cuts at some of the core of what it will take to sustain human life off-world, and we know that we're going to want to find things. We'll know that we'll want to measure, because that's what we do before we build things, and then we'll want to build. So find, measure, and build. And a key component to autonomy working to do those things is to be able to, well, measure your environment, right? The measure part. Australia has some world-leading capabilities in SLAM. The CSIRO team that participated in DARPA, and I noticed Jonathan's on, showed that they had some of the best, SLAM results that anyone had ever seen. So we think that there's a great deal of capability, and it seems worthwhile before NASA tries to invent its own version of SLAM. Let's go explore what the community in Australia has, because that's what we'll need to essentially measure and build the two of the components it will take for humans to live off-world and not have to do all the work themselves. Back to you, Michelle.
That's it from me now. These are the three opportunities. We invite you to put questions in the chat so that we can answer these at the end, but I'll hand back to Chris now to take you through the process.
Perfect. Thank you, John and Michelle. That was great. And they speak space better than I do. So that's why I let them go over the details of those opportunities. But as you can hear, as you heard, I guess, exciting, certainly opportunities for the Met sector and really core in what we do. So just a bit about the time frame and the process, and you can see it on the screen before you. The time frame we are working for is tight, and we know that. But that's life and that's innovation. So we need, from 1 week from today, on the 10th of April, we're asking that you submit your short form solution outlining what you have to offer. And from there, we'll shortlist companies and provide a more technical briefing to those shortlisted companies about a week later. So what we're expecting from the short form solutions. First of all, as I mentioned before, everything that you need, more information about these opportunities and how you submit your solution is via our Mine Innovate platform, which is our new collaboration and innovation platform. So you can see everything there. Again, the three innovation opportunities are outlined. It provides you with a bit more background and what we're looking for. The short form solution, it's pretty easy. You do complete it on the Mine Innovate platform. You will need to log in and create an account, but we simply need your company and contact details. We need a description of your solution. You can put it right into the online form, no more than 1,500 words, or you can attach a PDF document, a Word document, or a PowerPoint format to the online submission form. And then we also need some basic information about your business, a short company profile, no more than 3 pages. If you have part of a solution, if you want to work with others and you need a collaborator, please indicate that as well. We can try to link you with others who are working on a particular opportunity or opportunities so that we can really bring, the best of what Australia has to offer together and put our best foot forward for these particular opportunities. And again, after we receive the submissions, we'll get an expert panel together to recommend a shortlist. Just following the short form solutions, we'll have a technical briefing, as I said, on the 18th of April. Then we'll require a 3 to 5 minute video pitch, and the deadline for that will be the 3rd of May. We'll announce, then we'll assess, and we'll announce the shortlisted companies on the 8th of May. And then the opportunity will be for those shortlisted companies, for the finalists, I guess, if you will, to share what you're offering at the NASA-USGS workshop in San Jose, California in May. Now, it's a tight time frame to arrange flights and accommodation, and we realize that. So if you can't make it in person, we would welcome the presentation online, and we'll work with you to arrange how that will best work. I'll hand over to John. He'll talk a little bit more about this workshop and what to expect, but it's certainly an exciting opportunity for those companies who are finalists in this process. So, John, over to you.
Thank you, Chris. So, folks, the tight deadline is in part my fault for not, let's say, getting things going a little bit earlier, but the workshop itself is meant to develop a set of mission concepts that are premised on actual mineral exploration concepts of operation. So one of the interesting things that I and maybe some other folks with geologic backgrounds noticed when we got to NASA was that the folks who were looking for resources there had different concepts of operation than the ones that we learned how to use in the geologic industry. And as you will be familiar with on the line here, the geologic concept of operations to find things is to know as much about the structure in the subsurface and to differentiate rock bodies, as much as you can. And then it's guilt by association. You find certain geometries that are consistent or rock ages that are consistent. So that's a, let's say, time-proven concept of operations. What we discovered was that wasn't the one that the NASA folks were thinking about. They hadn't been exposed to it. And in addition to that, there were a number of places we recognized that there was underinvestment, both in Australia as well as elsewhere, and that underinvestment was largely in the sensors and the systems to drive those sensors around to image the subsurface. So a lack of a clear image of the subsurface meant there was more uncertainty, and that meant longer times to discovery, more expensive, because you have to start doing other things to buy down the risk. That same issue is true off-world. There's a common denominator technology challenge between the terrestrial drive to image the subsurface and the off-world one. And we thought, what if we brought together the off-world community to sort of introduce the problem? And then that's the first day of the workshop on the 21st. And then what if on the second day, we brought in the geological surveys from the Critical Minerals Mapping Initiative, that would be Geoscience Australia, the US Geological Survey, and the Canadians, to give us some broad guidance on, let's say, national imperatives to do that. And then we actually spent some time diving in with people like Michelle and Chris and others on how the mining exploration community uses technology to find things in the subsurface and what the concepts of operation were. And by doing so, we would introduce the NASA team to a different way of thinking about the problem, as well as a number of the resources that exist already within the METS community. And of course, Austmine is one house for those. There are others, and we welcome all of them. But by having that conversation, it seemed to us that we would essentially develop a much sounder approach to finding resources off-world than by simply going our own way and not learning from, let's say, the Australian experience or the experience of other mining exploration communities. So the workshop is designed to have that conversation happen, to develop 3 to 5 concepts of operation for, in this case, finding subsurface resources on the moon, and then to lead to a follow-on workshop where we would have industry give us, let's say, tighter requirements about what resources they are looking to find. That might be, zirconium for a particular kind of fiber optic cable. It might be volatiles to resupply fuel for satellites or, other lift vehicles, or it might be something we haven't imagined. So this set of workshops represents an opportunity for the geological communities to inform the NASA off-world community about what the, let's say, state of practice is, and what better place to do it than here in Silicon Valley, where there are a lot of resources potentially to drive both industry and government forward. So with that, Chris and Michelle, I can hand it back to you unless you want me to say anything more.
That was great. Thank you very much for that. And again, what a great opportunity to be involved with the workshop. So it's now time to open up for questions. I can see there's a couple in the chat, but we've also received some in advance. And so let me just ask the first question while others are thinking about questions to ask. And the first question we received is, I am interested in whether university researchers are eligible for these opportunities. And I guess, my answer to that is yes, of course. We're trying to get the best and the brightest and have an Australian collective solution here. But John or Michelle, do you want to answer that question?
Just echo what you've already said. I think even if you look at the Australian Space Agency, when they put out, they're trying to understand more about the MEX community. They really kind of clearly said we're keen to learn from commercial companies, researchers, academics. We realise at universities there are varying levels of technology advancement and a lot of great work happening. So we're keen to learn, from everywhere. And I think, as Chris, you mentioned earlier, there could be opportunity for different organisations to combine, what they do. So whether it's a university kind of on their own or partner with other organisations, we're open to all of that.
Agree. I think we're agnostic about the source. There's great ideas in industry and academia and in national agencies, and it's all about the people, right? The great people can be at any one of those.
Okay, thank you. The next question, will you accept any TRL level? That
seems like that might be a me question.
Mm-hmm.
Yes, and the short answer, Michelle, unless you want to take it.
No.
Okay. The short answer to why is that as the NASA mission directorates are thinking about sustainable human life off-world, right? Moon to Mars, as well as our Artemis Accords. They're going to be investing in technology at all TRL levels. So if there's a great idea out there about how to solve a challenge, to fill a capability or observation gap, even if it's an early TRL idea, it's worth getting in front of the guys and gals who are well in charge of thinking about these problems, so that they know that there are folks out there who are started to think about it too, right? So that's why any stage of TRL is of interest. Although admittedly, if it's still on the napkin, well, maybe it'll be less compelling. But if it's off the napkin, then yes, please.
I think the other thing to think too, even if it is early TRL, you're continuing to try and understand your business case, to try and understand, to test your business case with the potential end users or end customers out there. And so, by presenting what you have and where you see that going and the advancements that you'll be taking to accelerate the TRL level, the audience that you have here, is an audience that is looking at long-term application as well, and kind of any sustained presence on the moon. So really, if you think about that end game and how you want to test with different audiences, it is important to kind of think about this in that respect.
Excellent. Thank you for that. The next question, can you please give an overview of the IP rights for submission and for the project?
You take that one.
John,
Like, I mean, obviously at this stage there, you present what you're comfortable with in terms of information, but then moving forward with IP, I'll let you make a comment there, John.
Yeah, I think that's right, Michelle, is that you're presenting to a public audience, and so you don't want to present any protected IP to the public audience. If you develop a relationship with NASA at a later date, then there are a set of agreements that NASA uses that will protect industry IP or academic or other, let's say federal agency IP. But that has to come after there's a, let's say, more defined relationship. So you should treat the public presentation as if it's a public presentation. Don't present any protected IP there because, well, that's not in your interest. Having said that, it is true that if you are talking to only civil servants in NASA or USGS for that matter, there's a statute that says we have to protect your IP, right? You may feel that that's not sufficient and that you want to do an NDA, a non-disclosure agreement. Those have all been done, but that all presumes that there's after the initial public presentation, there's a further relationship to be developed. That may be the case. If that becomes the case, then there are steps that you can take that will protect your IP.
Excellent, thank you. The next question, for the first opportunity, which is obviously the minerals detection, what depth do you want the information? 1 centimeter, 5 centimeter, 10 centimeter, and also what spatial resolution?
Right. Well, I think that the short answer to that question is what we're looking for is a prospectability map that improves going to the, let's say, lunar highlands or the lunar lowlands for a particular element. So if it's 5 centimeters versus 10 centimeters, I don't think that's going to be dispositive. I think people will, either one is fine, right? Because it's an improvement over what I think is our current capability, which is not much. In terms of spatial resolution, again, even something that was, let's say you could find increased concentrations at, 10 square kilometers or something like that. That's still an improvement, right? Because then you could target that area to do a higher resolution survey. So I think that from my perspective, at least, anything that generates a prospectability map that improves over the, broad scale geologic maps that we have now would be an improvement and therefore worth listening to. I don't know if that answered the question. I'd be happy to, let's say, dive deeper into it, but that would be my first answer.
Excellent. And some of that might be answered in a more technical briefing that we'll hold later on during the process as well. So thank you for that. Okay, we only have one more question left. So if anyone has any burning questions they want to ask, please do so now. But the next question, is there an expectation of funding being available from the presentation to the NASA workshop or to cover costs to attend? Or is the main outcome of this opportunity to present? So I'll start by answering and saying, no, there is no funding to present at the NASA workshop or to cover costs to attend. That's why we've offered a low-cost option of presenting virtually. So you'll get to, present your solution, not be there in person, but it won't cost you very much money, of course. And so in a way, the main outcome of the opportunity is to present, is to meet people, is to get in front of NASA. But really, it's the bigger opportunity to start the journey, to be able to showcase what you have to offer and get involved in the space industry. And at the same time, meet a whole bunch of people who you'll be able to learn from as well. So John or Michelle, do you want to add anything to that?
Michelle first, then I'll follow on.
Yeah, I mean, other than echoing what you've already said, Chris, at AROSE, we're really excited that we actually have this conduit to NASA to be able to understand a little bit more about, what's important, both through the work that John's doing and other areas. Timing is important in whatever we do. And given where the space industry is going and the acceleration of development of what does a future lunar economy look like, what are the technologies needed, building out of the Moon to Mars architecture by NASA, across industry, the space industry, and now looking to the Met sector is an enormous opportunity. And so at AROSE, and with our members and the way we look at this really is about an opportunity to present what we have. Pam Malroy, as I mentioned right at the beginning, already acknowledged the capabilities we have in automation, and we continue to innovate around that every day. And I imagine many of you are already involved in either the work that's done up in the Northwest or other operations. And so if we're to accelerate what we do here, and the space sector is to also accelerate, taking advantage of this opportunity to present is enormous. Just really want to reinforce, I guess, the two-way transfer. We don't just think that this is about you taking your capabilities to the space sector, but if that collaboration can start and the discussions can start about where you can even improve what you have for what you do on Earth, imagine where that could take all of us in how we apply your technology, services, capabilities, and what we do in exploration and operations now and ongoing.
Yep. And I will camp on to those two fine answers and add that I think the opportunity here is to meet a bunch of impactful people who are driving the investment in this particular space sector. Just to illustrate some of the folks that we've met in the last year or so in Australia, we have, I think, 4 or 5 Space Act agreements going forward for in-kind exchange. Ultimately, we've entrained some of those folks in NASA proposal opportunities. And so it's not an empty gesture to say that if you have a capability that really resonates with finding things off world, that there's a pathway forward if you're willing to sort of be a partner and be patient on it. And so those opportunities are I think, worth at least thinking about. And I noticed there's another question in here, but I'll wait for Chris and Michelle to queue on that.
Yeah. Okay. Thank you for that. Yes, we do have one more question, and it is, are you looking for ultra lightweight platforms and drive systems additively manufactured?
I think that's for you, John.
Okay.
That's for you.
Yes. Well, so not surprisingly, because taking things up the gravity well costs money, if you can save weight, that's a good thing. So ultralight sounds pretty good, particularly if it means that you can put multiple different sensors on your platform. In terms of drive systems, additively manufactured, I'm not entirely sure. I think that sounds like a 3D printing capability for elements of the platform that involve the drive system. That sounds like a good thing. Those are both pluses. We do, one of the promises of finding resources off world is our ability to not have to spend a lot of energy moving mass around, but instead to process it in some fashion and then use it, closer to home. So additive manufacturing will play a big role in that, and the ability to, let's say, send plans up to the space station, send some electrons up there to print something out on the space station as opposed to having to haul it up. That's a pretty appealing idea. So yes, the ultra lightweight and additively manufactured is a net positive if the resource is, let's say, close by.
Excellent. Thank you for that. Okay, we don't have any more questions, and I'm sure everyone is anxious to get started on their submissions. So we'll wrap up here. Just a few reminders. Everything can be found on the Mine Innovate website. You will have information again about the innovation opportunities and more, and what you need to get started, including registering to submit your solution. If you have any questions or issues with the platform or any further clarification you'd like, please email us at admin@mineinnovate.com.au, and we will get back to you. So thank you for joining us today. What a great opportunity. This is a very, very exciting opportunity for the Australian Met sector, a recognition of our smarts and what we bring to minerals and mining on world, and why not take them off? So I'd like to thank Michelle Keegan. I'd like to thank you for your presentation today and for partnering with us on this exciting opportunity. And also thank you to Jonathan Stock from the USGS for joining us today for this very interesting discussion. And hopefully, John, we'll all see you in May at the workshop. So thank you very much, and we look forward to working with you further.